Welcome back, Calc. We're going to be working with net distance versus total distance. There's a big difference here, which we'll get into. And this is sort of a difficult problem that we're starting off with to really grasp as far as a visual goes. But what we're given is a velocity. I think just some people typically confuse acceleration because acceleration is the derivative of this, and you just sort of have to flip a switch. So this is definitely not a differentiable function, which is kind of why we have this statement of no acceleration. And there's two different ways that you can interpret this, so I'll answer both. I'm going to answer first an undefined v prime of t. So where we have sharp turns, but I could also understand why somebody might say that we're looking where v prime of t is equal to 0, because some people interpret no as being 0. Like if I have no money, I have $0. I get it. So depending on how you interpret that, maybe I'll do this one in this color. You're looking at those sharp turns. So at t equals 1, 3, 6, 8. I guess I could include 0 and 10, but let's just leave it as those are open because it's an open interval, so we can ignore that. And if you wanted to, I would be willing to, hear if anybody says for this answer, that interval between 3 and 6. If you wanted to include that as well, I would totally get it. Which is actually kind of leads us into the next one. Because remember, acceleration is the derivative of velocity. And so if we're tasked with finding this as a piecewise defined function, it's basically just saying what's the slope of every one of these pieces. So starting with the first piece as a slope of 3 between 0 is less than t is less than 1. So we're with respect to time. So then the next interval looks like it's negative 3. And that's between 1 and 3. And then we get a slope of 0 between 3, we kind of already discussed that, and 6. Really should have given myself more room, but then it's 3 from 6 to 8. And I'll just squeeze right here. Looks like it's down 3, right 2, so maybe just negative 3 halves between 8 and 10. Alright, so really wish I wrote smaller, but that's okay. As we move on to the next one, when the particle is moving to the right. Now think about what it means for the particle to be moving to the right. Well, that's where the velocity must be positive, greater than 0. So as we look at where the velocity is greater than 0, it's between, above the x-axis might be another way of saying it, would be between 0 and 2 and then 7. So on, I'm just going to give open intervals, by the way, 0 to 2, and also between 7 and 10. And there's my justification right there. That's the justification. And notice I'm giving the answer in correlation to what was given to me. So that means the particle is moving to the left where the velocity is negative, and that's everywhere else. And again, I'm just giving open intervals. I'm not going to worry about closed intervals right now. Okay, so the average acceleration. Whenever you see that phrase average, you should be thinking of a difference quotient. I don't know if I've said that before, difference quotient. So if I'm asking for the average acceleration, a of t, then what I should be seeing is v of, well, because they give you the interval, I would just do v of 8 minus v of 1 over 8 minus 1. So basically it's saying the average acceleration means the slope of the velocity over that interval, something like that. So That's what I mean by difference quotient. Difference because they're both subtraction, and then quotient because it's division. That's what I mean by difference quotient. So as you go back to the problem, well, v of 8 was 3, and v of 1 was also 3. So we're looking at 3 minus 3 over 7, which would just be equal to 0. 0 divided by 7 is still 0. Okay, so as a reminder, as we move on to the next thing, remember when we are speeding up, that means velocity and acceleration are the same sign. So this would be your reason as to, if they're the same sign, then we are speeding up. There's nothing wrong with writing your justification first and then go to the problem and say, okay, well, if I'm positive, I also need to be increasing. So you could even give that reason for why velocity and acceleration are the same sign. If velocity, and you can write down velocity, is positive and increasing, or negative and decreasing. That would be another good reason. That's all to say it's speeding up. So those are your reasons to say it's speeding up. I haven't given you the interval first yet. That was a terrible arrow. Please forgive me. Anyway, it should be from 0 to 1 though. But that's not the only time that it's positive and increasing, because even though it's positive here, it's decreasing, so that's not good. It's also positive and increasing from 7 to 8. That's not the only correct answer, because looky here, we have a negative velocity and decreasing. So it's from 2 to 3 as well. And then over here it's constant, so no. And then over here, no, it's increasing and negative. So 0 to 1, 2 to 3, and 7 to 8. And then the flip side of that would be velocity and acceleration are different signs. And this is where you could say velocity, I'm not going to write this, is positive and decreasing, or negative and increasing. So like you'd have to switch those words around. I'll leave that to you to write that. And that's where, not speeding down, that makes no sense. It would be slowing down. So let's look at the graph now. So if it's positive, then we need to have a decreasing graph. So that's 1 to 2, negative and decreasing. No, we already have that. Negative and a slope of 0, so no, not that one. Negative and increasing. Okay, so 1 to 2, 6 to 7, and also 8 to 10. 1 to 2, 6 to 7. And then 8 to 10. And feel free to write down some questions if you need, and come to Google Meet and ask them. Nothing wrong with that. So multiple ways of writing down your explanation of something like that. So as we move on to the next page, we have a lot of definitions. So you know me, I'm gonna go to the answer key because I like. Here we go. I like to make sure that I give you the formal definition instead of my words, because sometimes I trip over my words. So when we talk about net distance, we're talking about the difference between where you start and where you end. So think about like from your house to maybe school. Okay, that could be a net distance. You woke up in your own bed. You came to school. However, that might be different than the total distance traveled, because what you may have done this morning is you got up, remembered that you forgot, a textbook at your friend's house, so you went to your friend's house, grabbed the textbook, and then you're like, you know what, I still have time, I'll go get some coffee at Starbucks. So you drive over to get some coffee, and then you come to school. Well, the sum of all of those difference moved in any direction would be different than the net distance, because the net distance is just there and back. what's the, sometimes we use the phrase displacement, and I'll write that down. And we don't have another word for total distance traveled, so we just say that. So displacement, if you've seen that word before in physics, or total distance. Now, if you're always going in the same direction for the entire time, so you only went, I don't know, let's say you live west of here, so you only traveled east, and you didn't go back and forth anywhere, your net distance will be equal to your total distance, always. But now what we're going to do is talk about how we can find the net distance of a particle versus total distance of a particle. And notice that the absolute value here is just in case. Well, what if you went backwards? Well, then you'd get a negative answer. But just like with absolute value is always positive. Distance needs to be positive. So that absolute value is in there only if you went in the negative direction. So if you only want net distance, you just take where you ended and you subtract it from where you start. And if you switch it around, you just absolute value it. Whereas total distance traveled, you have to find the points where the object changes directions, and he labels those points as t equals c, and subtract them individually. So, and by the way, you might have more than one place where you change directions. So you might have multiple c values. So you just have to continue to add one way or another. And I don't want to rush through the next example, so I'm going to stop it right here. You might want to hit pause before I end the video. And I'll see you in the next one. Although I did want to write down that displacement. So if you're familiar with that word, it's the same thing as net distance. And in calculus, we just say total distance traveled when we talk about the other one.